Hello, class. This is Mr. Eggleston, and this is the quiz review for our last quiz, 8.1 through 8.6. This is the second time I'm going through this because technical issues jammed up my iPad. So here we go. All this is, in words, describe the transformation shown. So f of x is a rational function shifted right 1 unit. Okay. And that's it. Notice there's no plus number out here. If there was a plus 3, it would be up 3, or minus 3, that'd be down 3. But since there's nothing there, it's like having a plus 0, which means it doesn't move up or down. So it's shifted to the right 1 unit. It is stretched by a factor of 4. And also, reflected across the x-axis. Okay? And, now on question number 2, identify the vertical asymptotes, the horizontal asymptotes, domain and range of each. Well, the vertical asymptote is where the denominator of the fraction equals 0. In this case, that means x minus 1 must equal 0. That occurs when x equals 1. So that's the vertical asymptote. All right, the horizontal asymptote, the HA, is basically the idea when x gets big. Okay, if x gets big, this fraction with the x on bottom goes away. And you're left with y equals -2. If there's no number at the back end, if that was gone, then it'll be y equals 0 because there's no number at the back end. You can always put a plus 0 if there isn't any. So we got the vertical, we got the horizontal. Now the domain is all real numbers except x equals 1. Because x equals 1 gives you 0 on bottom, and you can't have that. The range is all real numbers except y equals -2 because that's a horizontal asymptote. And last, the horizontal, well, I should have said this, the horizontal, yeah, so I got everything. There's vertical, horizontal, domain, and range. All right, notice you exempt in the domain and range the vertical asymptote and the horizontal asymptote. All right, now, when it's like this is a generalized rational expression. They want you to analyze this. They want you to identify the wholes, vertical asymptotes, x-intercepts, and horizontal asymptotes of each. So the first thing you need to do is factor. So on the top fraction, you're looking for products that give you 12 but add up to 7. That's 3 and 4. On the bottom, you pull out the -4 because that's a constant. That's a GCF. And we have this. Then factor the parentheses. We still have the -4. What multiplies to -4 but adds to 3? That'll be x plus 4, x minus 1. So we get this. All right, so identify wholes. Vertical asymptotes, okay, the let's just go through the zeros because they're asking for the x-intercepts. The x-intercept is when the top equals 0. And that's going to be when x plus 3 equals 0, which is x equals -3, and x minus, or x plus 4 equals 0, which gives us x equals -4. All right, so we got two x-intercepts showing here. Then, vertical asymptotes. All right, that's the bottom equal to 0. So that means you'll have x minus 1 equal to 0, which gives us a vertical asymptote of x equals 1, and x plus 4 equal to 0, which gives us a vertical asymptote at x equals -4. Notice our 0 and one of our vertical asymptotes is at the same location. They cancel each other out. So it is not a 0, it's not an x-intercept, and it's not a vertical asymptote. We call this a hole. And basically, the way you look at it, you see the x plus 4 here. So that divides out with this x plus 4. It leaves a hole in between. So there's a hole at x equals -4. Okay? Now, we got holes, vertical asymptotes. We have not discussed horizontal asymptotes. So the horizontal asymptote is when x gets big. And the easiest way to figure this out is to have it in the non-factor general form. So, and when you do that, you look at the highest powers, the lead terms in each polynomial. So we're going to look at only these two, x squared over -4x squared. So y equals x squared over -4x squared. I don't care about anything else. It's just the lead term. The x squareds divide out, and that gives you -1/4. So that's a horizontal asymptote. And we answered all parts of that. Okay? All right. That's it on the analysis stuff of looking at rational functions and the behavior of their graphs. Now we're going to get into just basically how do you add fractions? How do you subtract fractions? How do you multiply fractions? And how do you divide fractions? So here we go. To add fractions, the denominators have to be the same. All right? And the way you find that is through the LCD. So you look for the LCD. Well, luckily for us, these are just two linear binomials on bottom. So the LCD is going to be each. It's going to be b plus 6 and b plus 4 multiplied together. What that basically does is when you add these, it will be b plus 4 times 5b over b plus 6, b plus 4, which is the LCD. Notice I had to add the b plus 4 on bottom because this has to reduce to what we started with. And then it's going to be 5b plus 5b times b plus 6 over b plus 6, b plus 5. Did I say 5? I'm sorry, b plus 4. All right? Again, I just want to pause here. Notice each of these fractions, if we were to reduce them, would turn into what we originally started with. That's the whole point of looking for the LCD. But now the bottoms are the same. So we're just going to distribute the 5b on top here. So 5b times b is 5b squared. 5b times 4 is plus 20b plus 5b times b is 5b squared, and plus 5b times 6 is 30b. All over this LCD. Notice I'm not going to multiply together the LCD. I'm going to keep them factored. Okay? So now, combine like terms. You get 5b squared plus 5b squared is 10b squared. 20b plus 30b is 50b. All over b plus 6 and b plus 4. That's hard to tell, but that's a 4. Okay? And that is the result. I guess you could factor out the 10b if you were of the mind. And that'll give you b plus 5. But that's not really helpful because you can't reduce. But you should always look, just in case you can, because it needs to be in reduced fraction form. And this would be the answer. All right? All right. Now, look at the next one. It's the same idea, but now it's subtraction, which makes it slightly harder because you have to remember you're subtracting, not adding. So the LCD would be v minus 4, v plus 1. All right? So we're going to rewrite each of these fractions over the common denominator. Okay, notice we had to add the v plus 1, so we have to add it to the top. And then it's minus 2v over v plus 1, which was already there. And now we're adding the v minus 4 to make it equal to the LCD, which means we have to add that to the top. Now it's over the common denominator, so we are just going to distribute and then combine like terms. So distributing on top of the left, that would be 3v squared plus 12v minus, and this has got to be careful, so I'm going to put a big parenthesis here, minus 2v times v is 2v squared. 2v times a negative 4 is negative 8v. But we're subtracting all of that, all over the LCD of v plus 1, v minus 4. Now combining like terms, remember when we're subtracting. So this subtraction is going to turn into addition by flipping the signs inside. And we have 3v squared plus a negative 2v squared. That comes out to be v squared. You have 12v plus 8v, that's going to be 20v, all over v plus 1, v minus 4. And just for giggles and grins, we can pull out a v on top and get v plus 20 over v plus 1, v minus 4. And that would be the final result. All right, so we have an addition and subtraction. And now we have multiplication. Multiplication is inherently easier than addition and subtraction. Actually, adding and subtracting fractions of unlike denominators tends to be kind of tricky. That because you have to find the LCD and such. Here, we're just multiplying, but I would recommend factoring whatever can be factored and seeing if we can reduce some of these. So we got 5p squared minus 30p, which means we can pull a p out. Actually, a 5p. That leaves us with p minus 6. And then on top, it's still 3p squared. The p squared and the p here on the outside divide out, so they're gone. On top here, you can pull out 5p. Oop, I don't know what that was. You can pull out 5p. leaves you with p plus 4 right here with a 3p squared on bottom. All right, this p and that p cancel out. And we're left with the 3p from here times, looks like a 5 is still there, and a p plus 4 is still there. And on bottom, we have the 5, this times 3 from here with a p times p minus 6. All right? The p's divide out. The 3's divide out. We still have the 5's divide out. And it looks like we are left with p plus 4 over p minus 6. And that is the multiplied product of those two fractions. All right? Last of these, and then I'm going to stop, and then I'm going to restart this because this is getting kind of long to do the last two, is now we are dividing two fractions. So the first thing I always tell my students, and you're my students, so I'm telling you, is let's go ahead and factor what can be factored. So we got 3 parentheses v plus 2 on this side. We have pull a 3 out, parentheses v plus 4 on this side. The v plus 2's divide out, and this is left with 1 over 3 divided by 1 over 3 parentheses v plus 4. Now, division can be turned into multiplication by flipping right and multiplying. So we're going to turn division into multiplication by taking the 1/3. Now it's multiplication. Now we're flipping this fraction upside down. So that's going to be 3 parentheses v plus 4 all over 1. Now, is there anything else that can be divided out? It's the 3. So the result is simply v plus 4, 1 times v plus 4 over 1, which is just v plus 4. All right? So the key here is to turn division into multiplication by flip right and multiplying. I'm going to stop and start another video so I can do the last two problems.